Right. Welcome to another PAVE virtual panel. Thank you all in the audience for joining us today for our latest discussion, Operational Design Domain, the Foundation of Automated Driving. As a reminder, you'll be able to find the full recording of this panel, as well as all of our previous virtual panels on our YouTube channel, website at pavecampaign.org, or social media at pavecampaign. Now for some introductions. My name is Tabitha Colter, and I'm PAVE's Director of Operations and the moderator for today's panel. We have two fantastic guests this week I'd like to briefly introduce before we dive into the conversation. First, we have Raunaq Bose, co-founder and CTO of Humanizing Autonomy. Raunaq, welcome to our discussion.
Hi, thanks very much for having me.
And our second panelist is Andrew Smart, a consultant with Stantec GenerationAV and AV safety and technical standards. Andrew, welcome to our discussion as well.
Thank you very much.
Great. So today we're going to be discussing a key concept of autonomous vehicle technology, the operational design domain, also known as the ODD. We'll learn what an ODD is, why it matters, and how it shapes the hardware and software of automated driving systems. Andrew, let's go ahead and get started with you with just a basic definition of operational design domain. What are we talking about here on the simplest level?
I think as the viewers are thinking now, just another three-letter acronym I've got to learn. It is the most fundamental, because in the simplest term, it's really the box in which the AV will operate within. And when I say the box, it really then becomes in different environments. Excuse me. It'll be the physical environment, the digital environment, and then the atmospheric environment. So if you take those three elements, but then that really comes within the box that the AV will be operating within.
Great. And Raunaq, is an ODD, is that a purely geographical constraint, or are there other ways that we define ODD beyond geography, things like time or weather and things of that sort?
Yeah, so exactly, going on from what Andrew was saying, is the box is both physical, digital, and atmospheric. It's not just a geographical constraint. If you imagine Soho in London or in New York or in wherever, it's very different in the daytime on a Wednesday than it is on a Friday night. So you can't treat these things as being the same, even if they are in the same geographical area. They're different scenarios. Lighting, weather, the context around the place is very important. The ODD should clearly delineate where and when a vehicle can operate, and to reflect which scenarios that they can technically deal with safely.
That's great. And I know, Andrew, you were mentioning the different acronyms and things to know. So, one way that we often hear to distinguish different levels of vehicle autonomy is the SAE 6 levels of driving automation. Andrew, I was wondering if you could talk about why ODD is so fundamental to driving automation in general and how that relates to those SAE levels just a little bit.
It's a good one. I think maybe just come back to what Raunaq was saying as well. Previously, or level 0, we'll start there, the fundamental, where there's no any type of assist involved. It is the vehicle capability combined with the human driver capability. And therefore, the ODD, in most cases, the vehicle can wholly outperform the capability of the driver, in most cases. Unless you're expert level, but to the general public. But when it comes to the ODD, you can then start talking, even at the most fundamental, is some people feel uncomfortable driving at night, for example. That's the human driver. So they're defining their own ODD in terms of their physical capability of saying, no, I would like to just drive during the daylight hours. Or some people find it uncomfortable driving in snow or other adverse weather conditions. So little do we know, we actually define our own ODD as physical drivers, and that's when it comes down to your level 0, when there's nothing else involved. As we start moving further up the levels, it's then the capability and the amount of human interaction, and I like to say the human responsibility here, because we are all responsible when we are actually at the wheel. And so as you go through level 1 and 2, it's the amount of either warnings you have, so there's no active support and assist and engagement of the system. And then that really goes up to where you get to level 3, where there is a human driver with systems to support and warn, but there's also an automated system there as well. And this is where you're playing on both sides. And this is level 3 is the one which is, I'm going to say, contentious, but the most challenging, because you have to depend upon the human driver engaging if the system decides it doesn't want to play anymore. But then when you go to level 4, it's basically the human is really just not involved in the driving process anymore. But that's where the ODD comes in, and level 4 becomes more, there is a constraint, a boundary, a box you're within. And then level 5 then becomes the Holy Grail. It's everywhere, as Johnny Cash once said.
Raunaq, I know many AV developers right now are focused on limited operational design domain systems, aka that level 4 automation that Andrew was just discussing. Could you talk a little bit about why the focus on that level 4?
Yeah, so I mean, as Andrew was saying, the level 3 is the difficult one, where you kind of have some human control and some AV control, essentially. What level 4 is basically assuming that the control from the human is not there, or is extremely limited. So when people are designing these stacks, they are assuming that there is going to be very limited or no human interaction within the ODDs defined in the level 4 space. I think in addition to the more clear delineation of level 4 as opposed to level 3, level 5 is also very, very far away. It's a very generalized one. Level 4 seems like a good place to start if you want to be an AV company. I think the other thing, probably from a practical point of view, is that the level 4 systems are essentially getting the fundamentals going. So building the kind of fundamental stack of path planning, of perception, of like getting wheels moving, getting the sensors built in, and so on. Where we come in as Humanizing Autonomy is to kind of help these fundamentals to expand to more human-facing ODDs, but generally they're starting from a point where they just want to get some vehicles moving autonomously, safely around specific areas, and this is essentially what level 4 is.
Right.
I think if I can just build upon that one, it's, you get between level 4 and level 5, I see it as dealing with a teenager. It's needs and wants. I want everything. Level 5, want everything. To me, I've been driving for several years now. And I worked out the other day, I've done probably nearly 1 million miles. So, and I've not seen everything yet. And I've driven on 3 continents and done many things, good, bad, and indifferent. I still haven't seen everything. From dust storms to turtles to alligators, you name it. But that's what we're saying, is you can't see everything. That's why it's almost, my belief is level 4 then becomes, you talked about geography, it's almost geographically constrained to say, within a contiguous US, this is what you're likely to encounter, albeit road debris is an example. That can be part of your ODD, what the vehicle will find on the road. And there's different types of debris, and you find different types of debris in different parts of the country, different times of the year. So there's certain things that are nuanced, whether you're in Florida, between alligators, turtles, maybe some bears. In Michigan, where I am, deer, certain parts of the year. So there's certain things that it's not just this, you've got to learn about it all. And I think it's, although we say level 4 and level 5 with very strict lines, I think it will be, as we have vehicles today, you have vehicles that are all-wheel drive that can go through many environmental conditions, and some vehicles that are just two-wheel drive. So there's limitations with the functional performance. I think people need to start looking through the lens as a teenager, I want all of it. It's a case of, well, let's put it into context of what the people really need.
Yeah, the way I think about it, I know there's lots of opinions on how people see these things. Is level 5 is this kind of goal, and then between level 4 and level 5 is this kind of unlimited spectrum. So basically, you can always progress towards level 5, but it's not entirely clear if you'll ever be level 5. But that's just the way I see things from a more like, practical point of view.
I totally agree with you. That's where you're heading towards, but it's then, as any vehicle program, it's starting off with basic requirements. Our thoughts are, people used to talk about, we'll develop this vehicle for different emissions for different continents or different countries. It's the same from an AV perspective. We're developing it for, if you're looking to drive in an inner city, in London, for example, well, if you still can get vehicles into the centre, you get the general gist, or you're somewhere in the Midwest in the United States, totally different situations. So should you be wanting to have all of that capability when I'll never drive my vehicle in New York or London or Boston? But I think that's where we're going to progress. And I think as people have realized it's difficult. And that's why people have stated, okay, we're maybe a little, not say foolhardy, energetic in terms of giving our predictions of when we'll be on the road with our level 4 vehicle. Reality has to set in. And we know we're still at, in a lot of cases, still in the R&D phase, progressing to some product development, but we're not ready for series production yet. And that's what people need to realize. We're talking about it because the fundamental to me, and this is the passion I have, is the safety element. If it can bring safety and reduce the number of fatalities, I'm all in. And that's where people need to be, but we don't need to speculate too much. We just need to get on and do it and be straightforward with the public as to what it is, when it is, and when you'll see it. So, sorry, I'll get off my soapbox now.
No, that's great. And I'm actually really glad you brought up safety because, Raunaq, I wanted to talk to you, your organization, Humanizing Autonomy, focuses on that interaction between automated systems and human behavior. And I know as part of that work, you all are pushing for an expansion of the ODD framework to better account for human behavior. Could you talk to us a little bit more about that effort?
Yes, of course. We're actually going to be releasing a white paper soon on this as well, so where you can see a bit more detail. But in general, there's kind of 3 things that we think can be improved to take into account vulnerable road users in the way that ODDs are defined nowadays. So the first is the way that road safety or risk audits are done. So mostly these audits don't capture the complexity of real world scenarios, especially in dense urban areas, say Soho again, in central London. While things like weather or traffic are analyzed, the only information about vulnerable road users in existing audits is through the analysis of worst case scenarios, such as when collisions have occurred previously on a selected route. These aren't completely representative of real world scenarios on a day-to-day basis, and other dynamics such as the interactions between different VRUs, say cyclists and pedestrians and so on. These collisions and these interactions are important too, and they will definitely affect the performance of any AV or driver assistance function as well. The second one, which is kind of related, is exploring the ODD complexities based on VRU characteristics, such as the density and types of VRUs, etc. So an example would be at peak time, say at 8:30 a.m. and 6 p.m. In the UK, you have groups of cyclists going down cycle lanes and on the road in London. So how can so those type of complexities are not represented in ODDs, in the current ODDs around vulnerable road users. And the third one is about, and this sounds obvious, but it's very important, is the effects of infrastructure and urban design on vehicle and VRU interactions. So these are things such as cycle lanes or bus stops. You would expect people to be closer to the road when they're near a bus stop. So these kind of dynamic events, which happen, they're not edge cases. These happen millions of times per day around the world. These interactions need to be accounted for as well.
Great. Well, we look forward to that white paper when it comes out.
Yeah.
And Andrew, I know your organization, Stantec GenerationAV, assists clients in deploying autonomous vehicle projects across the country. And I was wondering, how does ODD play a role in those deployment discussions that you have with those different clients and stakeholders?
Hugely, but I'll give further context. Where I was originally from within the automotive industry, we looked through the lens of the vehicle and vehicle performance. The road was the surface you drove on, and the driving capability was then with the user, the human driver. But now, as we see from ADS or an AV perspective, it then becomes very holistic. How the infrastructure and the vehicle must come together. So then, rather than just one lens, you've actually got to look through multiple lenses here. Different analogy, a box of straws. You can look through one straw, and that's the vehicle side. You look through another straw, it's the infrastructure, physical, digital, or atmospheric. That's where the ODD is in as well. But people need to look at it holistically. It's the full box of straws we're looking at here, and bringing together the working environment and the vehicle is fundamental, because now it's inextricably linked. And that's what Raunaq says is so important, because where we stand as we deploy more and vehicles, then we start seeing more vehicles on the road, it's the mixed traffic usage. So part of the ODD would be being able to interact with VRUs, vulnerable road users, and other human-driven vehicles. Or as I like to call them, the randoms, because that's what it is. Or maybe it's just me where I drive, but that's what we have to take into account. And dealing with the randoms is very, very complicated. Unless we go through, and as Raunaq said, when I go through an ODD or a route assessment and people talk about cycle lanes, I ask, is there a physical divide between the cycle lane and where the traffic is? And when they say, no, there isn't, and I said, well, last time I looked, paint didn't stop a car from hitting me. So we have to be very careful of how the interaction is when you have the vulnerable road users, the human-driven vehicles, and also the automated vehicle. So that becomes a real mixed bag there. And that's really almost the height of the complexity in my view.
Yeah, I know one series of questions we get frequently is, questions about how to understand the relationship between an ODD and the design of an autonomous system. Raunaq, I was wondering if you could talk us through how a stack or the sensing hardware suite might be different if it's designed for one ODD versus a stack that's designed for a completely different ODD.
Yeah, of course, I can start. So I think when you have one ODD against another, you're looking out for different things. So if we're sticking to an AV, autonomous vehicle context, then if you're in an AV in a dense urban place, then you might use at the very lowest level kind of detection models for detecting pedestrians and so on. Another extreme, if you have a mining AV near a near a mine, you would be using it to detect workers or specific safety hazards or signage related to that. So at the very lowest level, you might have fundamentally different models on top of having different types of sensors to detect things that are further away or nearer. In an urban driving scenario, you're not really looking that far ahead. You're looking in the next 20, 30 meters or so, generally, depending on the speed limits of the city. But also, I think something that's important to highlight here is you want to highlight the different confidence intervals that you're comfortable with in these different use cases. So if we look at an ADAS application, lane change assist, if you see a lot of commercial lane change assist functions, they actually have a kind of sensitivity dial. So depending on how confident you are as a driver, or how risk averse you are as a driver, or how confident you can predict or how much you trust the vehicle's sensing abilities, you kind of have a different risk perception and different confidence interval. So I think it's important to think about two main things. I'm sure there are many more, but the two main that come to mind are the fundamental perception of the space around you. So this can be with different models and different sensors. And the second thing is the confidence interval that ODD is comfortable with. So is this a safety critical feature, or is this a kind of nice to have visualization feature? Yeah.
If I can build on that, maybe as a small contrast, is looking at the level of complexity that Raunaq was talking about, especially in an urban environment. There can be a variation of speed, which then increases the complexity greatly. But in the US, there seems to be a movement very much towards automated trucks. And the movement to this really is looking almost as a business proposition on the ROI, when it's very, very clear from a commercial point of view, whether it's platooning or the automated element for the vehicles, there is a very large ROI there. And so the fleet customers are extremely interested. And even after where drivers or safety monitors or safety are in the vehicle, even as they're actually doing it for commercial use, so they're moving goods around. So the confidence level is growing. And as Raunaq was saying, then I look at the freeway model within the US, you'll have specific hubs where the trucks will be going through. Then it will really just primarily, it is running on the freeway, 70, 75 miles an hour, maybe 55 up to 75 miles an hour, high speed, but the road surface, the road geometry, the other users you're coming into, and a lot of work at the moment is happening in the southwest of the US. So the weather conditions are limited, or we're not talking South Dakota snow at the moment. We're talking Texas and Arizona heat. So the ODD is quite different, and it becomes a little more constrained. I'm not saying it makes it easier. That's a relative term. It is extremely complex. But even as Raunaq was talking the urban model, and you talk about the sort of trucking highway model, they are very different from an ODD point of view, and the sensor systems involved. But that's what we're working with at the moment. People are working on multiple ODD configurations and different applications.
Definitely. And Raunaq, you touched on this a little bit in your last answer, but we've mostly been discussing fully autonomous systems here. But for human in the loop systems, things like that level 2 that Andrew was describing, where it's the driver assistance system, does ODD play a role in those systems? And why would the ODD be important in those situations when there's a human involved who's ultimately responsible for the vehicle and is behind the wheel?
Yeah, I mean, it's absolutely just as important. I think the ODDs being defined in the AV space are an extension of the ODDs that get defined in the driver assistance space for human drivers. Human drivers need to know the limitations of their assistive systems, or at least the OEMs that manufacture the cars and work with the tier ones. They need to understand the limitations and communicate that clearly to the drivers. So I would say they're equally as important, because it's for the same reason. If you go back to the initial definition of the ODD, it's in which scenarios is the vehicle able to operate? And as Andrew was saying, that the vehicle in an AV is basically the machine itself and the sensor suite, and the vehicle with a human driver, essentially the car or the truck with the human driver's capabilities.
Andrew, I know that's a an important one to you too, as well, with the work that you do. And, you work a lot in standards and things on the industry side of things, but as we think about communicating that to the public. So did you have anything else to add there too about the lower levels?
Maybe I'm going to say it's a pet peeve. I have a huge bruise on my forehead, Tabitha. And this relates to people who refer to a level 2+ system. And you look around and go, what's that? And people just nod and say, oh yes, level 2+. And some of the manufacturers were using this term. Again, it's disinformation, and it's downright irresponsible because there's no definition to it. So maybe that's good, so they can carve their own path. But it is irresponsible, so people actually don't know what they're driving, or they don't know what to expect. I think with the even level 1 and level 2 systems, a fundamental is, I'm not going to call it training, it's the education for the user. I've just taken delivery of a 2021 car. I don't know, I just drove it home from the dealership. That's not acceptable, because you're driving a lethal weapon, both to you and the general public. So you need to fully understand what it can do. Because when the bells ring and the red lights flash and the emergency braking starts, what do I do? And that's something that I think the education to the drivers, and because the capabilities of cars or motor vehicles has increased greatly over the last 10 years. The capabilities of the drivers haven't. Driver training, licensing, what it's required to get behind the wheel. I'll give you maybe a silly example. So you can tell from my accent I'm an American, but I was parking a car, reversing into the parking spot, got out and I was walking away. Somebody approached me and said, "You must be from Europe." And I said, "I'm sorry, I beg your pardon." They knew at that point. I gave the game away. And they said, "Why do you say that? You could park that car." And I'm going, yes, I can. In fact, I can throw it in there, and I've got a pretty high probability rate of getting it in most times. But it's the rigor of which you train and test the drivers before you get the license to take the lethal weapon on the road. And I think it's then responsibility of both the training for the driver, fundamentals, because the highest death rate in teenagers is cars. There's a clue there somewhere. Then it's a case of when you take delivery of your new level 2+ car, or whatever it may be. And so to fully understand the capability. And once you've got that, these are the fundamentals to it all, Tabitha. And once you've got that, then people, I'm sure, will feel a little more comfortable with what they're driving, how they drive it, in what conditions they drive it. And when the bells go off and red lights flash, they know what and why, and they're not panicked by it.
Yeah. And before we wrap up, I wanted to turn it to you too, Raunaq, and ask if, do you have any suggestions for how ODD should be communicated to drivers in terms of their own training, what they should be aware of? How can we kind of best get that out to the public who are driving these vehicles out there now?
Yeah, I think one thing that I like to talk about when it comes to driver assistance systems is that the point of these systems is not to take away control from the driver. The point of these systems is to augment the vision of the driver, to augment the driver. So the whole point of them is to protect all road users. So the ones inside the vehicle, the passenger, the driver, but also the ones outside the vehicle. So other vehicles, pedestrians, cyclists, e-scooterists, people in wheelchairs. There's a whole spectrum of road users that need to be accounted for. So I think the main way that I would communicate ODD is to human drivers and the safety systems related to those are to understand that to understand the limitations of the systems that are there. On the flip side of them, trust them within the limitations that are defined. So, for example, you would trust your parking assist when you know that, okay, it's accurate to within a few centimeters or so on. you wouldn't trust it to be accurate to millimeters because your own eye can't judge that. So it's a kind of interplay between what is the human ability, or in the AV use case, the pathfinding ability of the AV, and what the sensors can, sensor and perception technology can give to the driver or the AV.
Thank you so much. Well, that actually wraps up our 30 minutes. That was super fast. But Andrew and Raunaq, thank you both again for taking the time to join us this afternoon to dig into this really important topic. And a big thank you to our live audience and everybody who submitted questions in advance. If you want to follow up with PAVE or one of the panelists on this topic, please reach out to us via our website contact form, or just go ahead and reply to your registration email. And as a reminder, we'll be posting the full video recording on our YouTube channel and website later this afternoon. Follow us on social media at PAVE Campaign to see that as soon as it's released. And real quick plug, please join us next Wednesday for our next panel in our AV Answers series featuring Laura Major of Motional. She'll be taking on your biggest AV questions, so register now and send those in to us on social media or on our website. Thank you all again.